So the next question on the Coulomb's law of electrostatic is two charged particles having charge of 2.0 into 10 power minus 8 coulomb each are joined by an isolating string of length 1 meter, and the system is kept on a smooth horizontal task. The tension in the string is so. In this question, they have given two charged particles. Two, two charged particles. Let us assume that is Q. Both are equal, separated by a distance of 1 meter, and the charge Q is 2 into 10 power minus 8 coulomb. So they asked, yeah, not they attached both the charged particles by a string, so it it um, behaves it experiences a force of electrostatic and a tension in the string also. So they asked to find the tension in the string, nothing but the electrostatic force, because both will act opposite to each other. So F is equals to tension. So the tension will become K Q1 Q2 divided by R square, right? Along with negative sign. Minus 9 into 10 power 9 into 2 into 10 power minus 8 whole square divided by 1 whole square. So 9 into 10 power 9 into 4 into 10 power minus 8 divided by 1. 9 into 3 36 into 10 power 1 10 power 10 power minus 7. So if we shift the decimal to the left, it will become 3.6 into 10 power minus 6. If we this is a tension, so the force will be always a scalar quantity, so the tension will be of 3.6 into 10 power minus 6 Newton. So the next question will be, two electrons separated by distance r experience a force F between them. The force between a proton and a singly ionized helium atom separated by distance 2r is. So first they given two electrons separated by a distance of r experiences the forces F. So F, this is a common thing, and another condition they given as one proton is placed here and one ionized helium is placed. One ionized helium means the helium with one electron is given out, or it is shared to another. The distance between the proton and ionized helium is 2r, and a new force will be acting between them. They are asking the new force in between the proton and ionized helium in terms of the old force F. So this is the force between two electrons, and this is the new force, that is force between proton and He plus ionized helium, right? So we need to find the first force between two electrons. F is equals to k q or e square. E square is the electron charge divided by r square. This is equation 1, and the new force will be F dash. So k, the magnitude of the or magnitude of the charge of the proton and electron is same, so we need to either write E or P, and in helium, the helium plus, there will be only one E, and the distance between them is 2r whole square, and F dash will become as ke square by 4r square. So the answer will be F dash is equals to ke square by 4r square. In terms, if we write in terms of previous force, it will be like 1/4 of the previous force. And the next question is, two charges of equal magnitude and at a distance r exert a force F on each other. If the charges are halved and distance between them is doubled, then the new force acting on each charge is. So in this case, they given two charges of equal magnitude, two charges of equal magnitude and at a distance of r exerts and force F, right? Let F force will be equals to k q square divided by r square, because the magnitude of both charges is same, so kq square by r square. So they made changes. If the new charges is half of the old charges and the distance between them is doubled, the distance between is doubled, and then the new force they are asking in terms of the old force. So new force will be equals to k new charge whole square divided by new distance whole square. So k new charge will be half of the old charge, and new distance is double the old distance. So k q square by 4 into 4r square. So answer will be kq square by 16r square. The new force will be kq square by 16r square. In terms of old force, it will become 1 by 16th of the old force. So the next question is, the force between two similar charges of magnitude 2 coulomb each separated by a distance of 2 kilometer is. They are asking the force between two similar charges. Again, two similar charges that let be charges v equals to q. The distance between them is 2 kilometers, and the charges will be of 2 coulomb. So they are asking the force. Force is how much? Force is equals to k q square divided by r square. So here r is equals to 2 kilometer, which is in terms of meter is equals to 2 into 10 power 3 meter. So F is equals to minus 9 into 10 power 9 into 2 to the 4 into that's it, divided by a whole square 4 into 10 power 6. 4 will get cancelled, so the answer will be 9 into 10 power 3 Newton. If the force is minus 9 into 10 power 3, and the magnitude of the force will be of 9 into 10 power 3 Newton. The next question is two positive uh, two positive ions each carrying a charge q are separated by a distance d if F is a force of repulsion between the ions. The number of electrons missing from each ion will be E being the charge on an electron. This is an AIPMT 2010 question. So here two positive ions are given. Each carries a charge q. Each carries the charge q given as separated by two separated by a d distance. The the charges are q. Uh, the both the repulsion both the ions have the force of repulsion of F, force of repulsion as F. Um, they are asking that the number of ions, the number of electrons missing from each ion will be, right. First we need to find out the force between them, the repulsive force between them, like q square divided by d square. Yeah, once if we find the force, and then by the force we can find the charge. Charge is equals to f d square divided by k under root. So we know that q is equals to n into e. So q is equals to n e is equals to f d square divided by k under root. So they ask to find the number of electrons missing from each ion. So number of electrons n is equals to under root f d square divided by k divided by e. For simplest form, we can write f d square divided by k e square under root. So these are the number of electrons missing from each ion.